Or, I have the chat on the side. If you have questions about the examples we do, just let me know. It's on Canvas. So it's available tomorrow at 6 in the morning. It's due Friday the 17th at midnight. I'll send out an email and an announcement to everyone tomorrow as a reminder that you need to be working on your test. And I have a goal to check my emails tonight. It might be tomorrow, but if anyone's asked for time on past assignments, I'll get to that. I also have some grading to do. So we'll try to work on bringing up the grades before the very last day of the semester, which is the 17th. After that, I'm going to start putting your final grades into the official gradebook, and I won't be able to make any changes. Okay, today is our very last meeting, and we're going to finish the review for the final. No Zoom meetings next week, and I'll talk a little bit about the test before we jump into doing examples. If you want to meet with me in my office hour or during class time, you need to send an email to me and we'll set up an appointment. Otherwise, I won't be at the meeting. Okay. So the final exam has 10 questions. I've been doing examples that are similar but different to those questions. We'll try to get through as many as we can today. And then during this week, you can open the test and work on it. I don't think it has a save option, unfortunately, but you have unlimited attempts and there's no time limit once you start the test. Feel free to ask questions if you get stuck. I want to give you the highest score, and if you show work, it helps me to give you more credit for a problem because I can see where a mistake was made. If you just put down an answer and it's the wrong answer, you kind of have to take away points. Okay, and I guess last note is don't leave a question unanswered. Even a guess is better than blank. I can at least give you some partial credit for putting down some kind of attempt or scratch work or something. Cool. Okay. So we're going to get back to the review for the final exam. Okay, I think we're going to just jump into factoring. There's different ways to factor these problems. I like to use this grid method, and I'll explain it again. So we're going to factor x squared minus 6x minus 10. Okay, actually, I think what I'll do first is take out the greatest common factor, which would be 2. I can factor out a 2 from every term, so we'll start. Come back over, start with that. I guess divide each term by 2. Okay, as scratch work, maybe like on a different part of your paper if you're taking notes. fun factoring what's in the parentheses. 2x squared minus 3x minus 5. I like to draw the grid and you keep that minus sign with the middle term. That minus sign goes on that last term. Over here, you pick two numbers that multiply to 2x squared. 2x times x. On this side, I need two numbers that multiply to -5. -5 and +1 is a good try. Let's see. Let's at least put down 5 and 1. If there was a negative sign here, I would get -5x on the side. Kind of need room for the sides, so it's the same idea, just try again. Okay, put the 5 here and a 1 here, and I was going to try a negative sign there. And then this would give me x times -5x is -5x. 2x multiplied with 1 is 2x. And then you add the sides. So it would add to -3x, which is the middle term. So I actually got the right guess in the first try. Okay. So what's in the parentheses? The 2x squared minus 3x minus 5 factors into 2x minus 5 times x plus 1. And that's like fully factored. So there's your answer. Factor. It's x squared plus x minus 30. Okay. So we'll put the x squared, x, subtract 30. And you want to keep that plus sign with that x, that minus sign with 30. Okay. And again, here you get two numbers that multiply to x squared. So it'd be x times x. And two numbers that multiply to -30. I'm going to put a little list of options on the side, just in case, or just to point out like things, guesses we could try. Like 1 and 30 is one possible attempt with a negative sign somewhere. You could do 2 with 15. Again, one of those numbers would need to be negative. 3 and 10. 6 and 5. One of those numbers is negative. Okay, I think let's try 6 and 5. We'll put the negative sign here to get started. So multiply across to get x times 5 is 5x. X times negative 6 would be negative 6x. We add the sides together and we'd get negative x, but we want a positive x. So we'll try guessing again and we'll just put the negative sign on the number instead. So multiply to x squared, we have to make x times x. Two numbers out multiply to negative 30. This time we're going to try positive 6 times negative. Okay, this way is 6 times x. This way we get negative 5x. And you add them together to get x, which is my middle term. Okay, so we're going to take this and write it as its factored form, which will be x plus 6 times x minus 5. And that's your factored form. All right, the next topic is about inequalities. And be sure that when you do your test question, your answer is written as a set in interval notation. So inequalities plus interval notation. Okay, on one side of the inequality sign is 2x minus 4. It is less than or equal to negative of 3x minus 1. Cool. First, we're going to distribute the negative sign. Of course, you can solve this problem in different ways. This is just my first step. We're going to have negative 3x plus 1. Let's get our like terms together. I will add 3x to both sides. And then copy down the sign just as it is. Like, don't forget that equal sign underneath. Okay, 5x minus 4 less than or equal to 1. Add 4 to each side. Here we have 5x. And it's less than or equal to 5. So we're going to divide both sides by this 5 to get that x isolated, and that's how we're going to solve x. X less than or equal to 1. So the solutions are values of x that make this statement true. So any number that is less than or equal to 1. You can include 1, something like 0 is less than 1, any negative number, negative 10, that's less than or equal to 1. I think what would help is to draw a graph. So I would do a quick sketch of your graph of the solutions. You need to put 1 on your graph. You can include 1, so we'll put a little dot that's filled in. And then I suggested earlier that you test a point on either side of 1, not including that number. Like we could test 0. They're less than or equal to 1 would be true. So that is a solution, and you'll find solutions on this side. If you want, you can also test a number greater than 1 and see that it's false and that there aren't solutions over here on the other side. Let's put in just 2. Okay, is 2 less than 1? No. Is 2 equal to 1? Nope, so that's false. You don't want to shade over that number. It's not one of your solutions. We've shaded over the other side, which goes from negative infinity up to positive 1 and includes that value. So now we're writing our solutions as a set. The set starts at the smallest value, which in this case is negative infinity. Negative infinity and positive infinity always have a parentheses on the side. Go up to 1. Include 1 with a square bracket. If you have trouble with any of these symbols, you can kind of explain what you need. Like someone on the test put that you'd have 1 and then followed by the word square bracket. So if it's tricky to type this set, you can just try to explain what the set would look like. Another suggestion is you could write a parenthesis, go with negative, and then dispel infinity. Go over to 1 and put a square bracket. Most keyboards have a square bracket though, and a parenthesis sign, so it's shouldn't be too hard, but still, I understand that typing these things isn't easy. Okay, I'm going to do 2 more of these. Solve and write the solutions in interval notation. We have negative 2/5 x less than or equal to 4. I'm going to, we'll copy it down, do scratch work. Okay, so I want to take care of 2 things in one step. I'm going to take care of this fraction by multiplying both sides by 5. I also am going to take care of the negative sign. So I'm going to multiply both sides by -5. When you multiply or divide by a negative number, you need to flip the sign. Since I'm going to multiply by -5, I'll have to flip this around. You multiply both sides. Okay. So chose -5 again to get those, the negative with the negative to be positive and the 5 with the 5 to reduce to 1. And what's left is the 2x. Multiplied by a negative number, so we flip the sign, and then on this side is -20. Okay. We're just solving for x, so divide both sides by +2. So when it's a positive number, you don't worry about flipping the sign. You just copy it down how it is. This side has x, this side's -10. And solutions are values of x that make the statement true. The solution set is every x value is going to include every x value that makes the statement true. I have an easier time finding that set with a graph. You put down -10. We will include that number, solid dot. And then numbers greater than or equal to -10. So 0 is greater than or equal to -10. Positive 100 is greater than or equal to -10. So we're going towards positive infinity this time. Or you could test some points if you want to, some values of x. To get the solution set, which starts at -10, so we want a square bracket on that side. It goes over to positive infinity, which I'm going to just spell. If you can find this symbol, or if you want help finding the symbol on Canvas, let me know. And then you need a parenthesis on infinity. Okay, that's your solution set in interval notation. Last one for inequalities and interval notation. You missed a part. So we're writing the solution set in interval notation. This time we have -3 greater than -x minus 4. Okay, I'm just going to copy down the question or the inequality. And there's only one value of x so far, so I don't have to worry about combining like x values. But there are these numbers here. We could add 4 to both sides. One greater than x. We have to take care of that negative sign. So we could either multiply both sides by -1 or divide both sides by -1. In either case, I will have to flip the sign. I'm going to just multiply both sides by -1 is not less than positive x. To find the solution set, to find the set that contains all values of x that make this statement true, I like to draw a graph. So I put -1 on the graph. We don't include that number, so there's no equal sign. So we'll have an open circle. And then I could pick some values of x that make the statement true. Or I could test some values of x if I want to. X is greater than -1. So I could put 2, I could put +10, +20, going this way. There's positive infinity. Some number like -5, I put that here, is -1 less than -5? No, it would be false. So we don't shade this side. You'll find that there are no solutions on this part of the graph. Okay, so when you write the set, you start with a smaller value, go over to the larger value on the right. And we're going to start at -1. You do not include -1 because there's a strict inequality. Go over to positive infinity. And infinity always has a parenthesis. It's never going to be included in the set. Okay, next. We worked with radicals. So I have a couple examples for simplifying radical expressions. Okay, we're going to start with a cubed root of -72. A to the 4th and b to the 15th. Okay, just copy this down to get started. So reminder, if there is an odd root and a negative number under the root, you can just bring the negative out to the front of the root. We're going to start there. Also, if I can have a power under the root that matches that root, they'll undo each other. So what I'll do with a to the 4th is write it as a times a cubed. For b to the 15th, I'm going to write it as b to the 5th cubed. I'm trying to get that power 3 to match that root 3. Same with this one right here. They'll match up. And also, let's go over and factor 72. Let's do times 36. And factor 36 as 6 times 6. 6 is 2 times 3. 6 is 2 times 3. So 72 is 3 squared times 2 cubed. Let's put that back. Okay. Let's start bringing some values out from under that cubed root. And it only happens if we can have that power match the root. So I can bring out 2, but the 3 squared has to stay. It already has a power that's less than the root, so it's not going to simplify. Okay, we're bringing out 2. And this a right here. And this b to the 5th. Since that a has a power 3, and b to the 5th has power 3, they can both come out of the cubed root. So under that cubed root is the 9 times a. Let me take out that 2. Before we go on to the next one, I want to point out sort of a maybe shortcut. So after doing a lot of these problems, you can kind of notice that I still would have to factor 72 and do the sort of work that I got the same way. But for the variables, you can take 3, see how many times it goes into 4, 1 time, then the remainder stays under the root, which would have a remainder of 1. So there's 1a that comes out of the root and 1a, the remainder part, stays. Okay, then this part, take that 3. How many times does it go into 15? 5 times. That part right there, b to the 5th. No remainder, so no b's left over under the root. All right, next one. We want to simplify the following radical. Under a square root, we have x to the 8th, y to the 12th is over 4. Okay, first I'm going to take the rule for division. If I have the radical of that numerator divided by the denominator, and take the radical of the numerator and then divide by the radical of the denominator. The same root as I had, which is the square root. And if there's no number as part of the root, you just have to know that it's supposed to be a square root. I'm going to rewrite x to the 8th as x to the 4th squared. To get the matching power and root. And then for y, we'll write it as y to the 6th squared. And then 4 is 2 squared, and that's underneath the square root. Okay, so that root and that power match, which leaves a 2 in the denominator. Okay, then I got this root to match with that power, which would give me x to the 4th, multiplied with y to the 6th, since that power and root also. And then just talking about that shortcut again. So you have a square root. You can take 2, see how many times it goes into 8, which is 4 times, no remainder. 2, how many times does it go into 12? 6 times, no remainder. And then over the root of 4, which was 2. Let's see, I think we might do one more radical kind of problem. This is a 4th root of 48x to the 14th. Times y to the 23rd. All right, as part of scratch work, I'm just going to start factoring 48. It's 2 times 24. It's 2 times 12. It's 2 times 6. It's 2 times 3. So at first I'm going to work on getting somehow like a power of 4, and that would match with my root 4 and help me simplify what's under the radical. After we do this kind of work though, we'll talk about that kind of shortcut. All right, so far factoring 48, we get 2 to the 4th times 3 multiplied with the x to the 14th. So let's write that as x to the 12th times x squared. 12 plus 2 is 14. And then for y to the 23rd, let's do y to the 20th times y cubed. Okay, I'm going to go ahead and bring out this 2. That 2 right there is a power 4, which matches the root 4, and just out from under the radical. This 3 has power 1, which is less than the root, so it stays under the root. It stays under this root 4. Okay, with x to the 12th, I'm going to write it as x cubed and then to the 4th. Multiply with x squared. For y to the 20th, I have y to the 5th to the 4th. And multiply with y cubed. And all of that is underneath that 4th root. Okay, so I already brought out that 2. I can take out x cubed and multiply with 2. Multiply that with the y to the 5th. And then everything else needs to stay underneath the 4th root, meaning that 3 times the x squared multiplied with the y cubed. Okay, so talking about the shortcut. Let's go over here and take that root 4, see how many times it goes into this power 14. 4 goes into 14 3 times, which would be 12, with 2 left over. So there's that 3 times and the remainder of 2. Okay. How many times does 4 go into 23? 4 times 5 would be 20, so 5 times, with remainder 3. Got a y to the 5th, and that remainder is a y cubed left underneath the 4th root. Okay, we're going to move on to something different. Oh, thanks. We're going to solve for x. And we've got x, it's 3x plus 4 in parentheses. And then squared and equal to 25. Start with this copying this down. I'm gonna put a little space here actually. All right. What I would like to do is use the square root property. And when we square root both sides, we're gonna have a plus or minus in front of the root of 25. So that square root will undo that power, and the square root over here needs to have a plus or minus sign in front. So what's left is 3x plus 4 equal to plus or minus the root of 25, which is 5. Okay, we're solving two separate equations. First one, we'll use 3x plus 4 equal to negative 5. And then later we'll solve 3x plus 4 equals positive 5. Okay, subtract 4 from each side, you'd get 3x equal to negative 9. Divide both sides by 3. Got x equal to negative 3. That's just one solution. Okay, the other one is from 3x plus 4 equal to 5. Same kind of idea, subtract 4 from each side. And divide both sides by 3. Okay, and one more problem with this. You're going to solve for x. You will solve. Okay, on this side, in parentheses, is x plus 1 squared. And on the other side, we've got 36. Okay, so we're going to do the same steps with the square root property. To take care of that power 2, we'll take a square root, or root 2. And we'll root this side as well, and we'll put a plus or minus sign in front of that root. Okay, on this side, I've got x plus 1. Is equal to plus or minus the root of 36. And root 36 is positive 6. And you get the plus or minus sign from the square root property. Okay, we get two equations, one with x plus 1 equal to positive 6, and then we'll have x plus 1 equal negative 6. And let's do this. Start with x plus 1 equal to positive 6. Subtract 1 from each side. I got x equal to 5. Or you put x plus 1 equal to negative 6. Subtract 1 from each side. X equal to negative 7. Okay, there's two more kinds of questions. One about functions and one about logs and exponents. So we're going to let f be a function. Okay, so f of x is x squared plus 6x plus 1. Okay. We're going to find two values. Find f of negative 1 and f of positive 2. Okay, starting with f of negative 1. So what that kind of says is if you let x equal negative 1 and put it through the function, what would f of x be? So you input negative 1, find the output. I think it helps if everywhere you see an x, you put parentheses, and then inside of the parentheses, put the input negative 1. Negative 1, square it, add 6 times negative 1. Negative 1 squared is 1. 6 times negative 1 would be negative 6. So if you add negative 6, you're going to subtract 6. And then add 1. So 1 minus 6 is negative 5, plus 1 is negative 4. Okay, we're going to work on the other part of the problem, f of 2. So if you input x equal to 2, what's your output f of x or f of 2? So you're going to put some just parentheses every time you see an x. Put that input into those parentheses. All right, 2 squared is 4. Then you're going to add 13, 14, 15, 16, 17. Okay, so I want to talk about what's going on here just a little bit. And the notation, I think, takes a bit of time to get used to. So on your, or in the graph of the function f, we have found 2 points. Okay, so the first point comes from here, where you have x equal to 1, and then f of -1 is the output, -4. The other point on the graph of f is where you have x equal to 2, and your output, f of x, or we could call it y, would be 17. So this is your, I'm just trying to help you to get used to the notation and know which things are going where. So this is your x, and this is your f of x. Same thing here. That's your x value, that's your f of x value. Or you can call it x then y, like we've done earlier in the class. All right, let's use a new function. So this time we'll call the function g and input 2 numbers through that function. Okay, g of x is negative of x minus 3 squared. And then I put plus 1. Okay, find g of, do g of 0 and g of -2. So putting in x equal to 0, and then output negative of 0 minus 3 squared plus 1. So it's a negative of -3 squared plus 1. And -3 squared is 9. So you have a negative of 9. And then add 1. You have -8. G of -2. You have your negative, and then put in -2 for x. -3. That's weird. Okay, that negative sign is copied down. In the parentheses is -5. I'm going to square that. -5 squared is 25, and then it gets that negative sign out front. So -24. And then yeah, the time. I'm going to do a very quick sketch. So when we input 0, we output -8. Okay, 0 goes to -8. And then when we have x equal to -2, g of x is -24. -2 goes through the function g. The output would be -24. Okay, let's move on. So the last kind of question is about exponents or logs. Depends on how you want to solve the problem. We're going to use 4 to the power of x minus 5 equal to 64. Okay, there's a few ways to solve the problem. There's one way where I can get both sides to have base 2 and then use exponent rules to rewrite those values. Or we can have both sides have base. Or we can write both sides with base 4. Either way, we'll get the same answer. I think I'm going to use base 2. So if you factor 4, it's 2 times 2. So replace 4 with 2 squared. And then copy down the power that was on 4, which is x minus 5. We're going to factor 64. Eight times 8. Each of these is 4 times 4. Each of those is 2 times 2. So it's 2 to the 1, 2, 3, 4. Wait, that's too many. Let me back up. It's fine. I'm just gonna factor it differently. Let's go with 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, and that's 2 times 2. 1, 2, 3, 4, 5, 6. 2 to the 6th. The next step we'll do is to have that power multiplied with that power. 2 to the power of 2 times x minus 5 equal to 2 to the 6th. Okay, so I have a base 2 on both sides. That means the exponents have to be equal to each other. We'll have 2 times x minus 5 equal to 6. And then solve for x. I would divide both sides by 2. Okay, and then add 5 to each side. Okay, let x equal to 8. I think we might be out of time. Let's see if I could. Okay, I'm going to try to squeeze in one quick example, and let's say that you've already kind of, just to show you how to use the rule. Let's say you've done some work and you get your problem to look like this. We're going to have 3 to the x plus 2 equal to 3 to the 7th. Okay, when the bases are the same, like this 3 and this 3, the exponents need to be the same. You have to have x plus 2 equal to 7. We'll subtract 2 from both sides. I get x equal to 5. Okay, so that's it. You should be able to do your final exam with these notes. Stay if you have questions. Otherwise, good luck on your finals. Have a good winter break, and thank you for a great semester.